Okay. So as I was saying, guys, yung process ng multiple linear regression natin, pag if we run it through R, then R will automatically generate a model where you have the significant variables and then the insignificant variables. Unfortunately, guys, ang ginagawa natin, tinatanggal kagad natin lahat ng mga insignificant, tapos ito na yung model natin. But it's possible that there are some insignificant variables who should have been significant because perhaps of multicollinearity. So what we do is to remove variables one at a time. Hindi siya pwede yung ginagawa natin dati na tanggal na lahat ng mga insignificant. Yung natitirang significant, yun na yung model. So we do what we call stepwise regression, and there are three kinds of stepwise regression. Meron yung forward regression, where you start with nothing, guys, no independent variable, and then you put one independent variable at a time. Once a variable is placed there, hindi na siya pwedeng tanggalin. And then you also have backward regression, where you use all your independent variables to model your dependent variable, and then remove one at a time yung mga hindi significant na variables. No? And we said that the basis for this is the highest p-value or the lowest absolute value ng t-stat. And once a variable is removed from the model, it cannot enter the model again. No? It cannot enter the model anymore. And then there's this stepwise regression na nagsisimula siya forward, pero it's a mixture of forward and backward. Kasi magdadagdag ka ng variable, tapos magdadagdag ko ulit, pwedeng matanggal yung dinagdag mo na variable. So it's a combination of forward and backward regression. Okay? Now sometimes the results of the three models might be different. Okay? So it's up to us to really determine kung ano pa talaga yung gagamitin natin. No? Kung titingnan natin based on AIC, based on p-values, and also, syempre, hindi naman natatapos dun sa model selection lang. We will have to run our model through diagnostic tests. Titingnan natin yung multicollinearity ng mga independent variables, titingnan natin yung heteroskedasticity, titingnan natin yung normality ng residuals, and that's what we call the diagnostic test. Hopefully, makaabot tayo ngayon dun. Kasi so far, ang ginagawa pa lang natin, guys, is model selection. Given these independent variables, ano yung final na model natin? Okay? So that we did last time. All right. So kindly open the RMD file wage interact class that I gave you. In order to save on time, guys, andito na yung mga code. Pasensya na kayo, guys. Wala na kasi time. Kaya linagay ko na yung code dito. I'm sorry for this. I hope you still practice with it, guys. What we usually do is, di ba, ang ginagawa natin, I give you the file, empty siya, tapos kayo nagko-code. But in the interest of time, guys, kasi talagang kulang na tayo sa oras. Gusto ko, guys, umabot man lang tayo sa time series, ARIMA, kasi part ng syllabus natin yan eh. Parang nakokonsensya ako, guys, kung hindi man lang natin naaabutin yung time series, tapos pagpunta nyo next term sa research, na hindi nyo lang alam kung ano yung ibig sabihin ng ARIMA, hindi nyo PACF, ICF, but definitely guys, dapat makuha natin yon, yung GARCH, ARCH, etc. At least umabot sana tayo ng GARCH para pagdating sa next term, at least familiar kayo dun sa model na yun. In fact, there are several papers. Last term, I think may 2 papers na gumamit ng GARCH model. Ngayon, meron akong ina-advise na GARCH model din ginagamit nila. So that when you reach recipe, hindi kayo at a loss kung makakita kayo ng GARCH. Ano yan? Ano yung GARCH na yan? Okay, so we will definitely discuss that in whatever way, guys. All right. So may dinagdag ako mga library dito, guys. Si Psych at saka si SchemR. Si Psych we have used before. SchemR, I don't think we have used that. That's also good for descriptive statistics. So ang suggestion ko, guys, i-type nyo na lang dito sa console yung install that packages. If you have not, can you see the screen, guys?
Yes, sir.
Okay, so here, pag may R markdown ako, guys, kunyari may i-install akong package, dito ko na siya tinatype sa console. para hindi na magagalaw yung yung R markdown. Okay, because you can still type codes dito sa console natin. So if you haven't installed the package, just package guys yung SchemR, kindly install that now. And if you have finished, then let's require the packages OLSRR, Psych, and SchemR. Okay, I'm not going to install SchemR kasi meron na ako nun. Okay, sige. Meron na kayong na-load nyo na si OLSRR, na-load nyo na si Psych. How about si SchemR? Na-install nyo na, tsaka na-load nyo na. Guys, since konting session na lang tayo, sana pag nagtatanong ako, mag-feedback agad kayo, ha? Kasi minsan yung lull, yung ganyan, yung answer na lang kung hindi pa o yes, so that I know, guys. Na-load na ba?
Ako ini-install ko pa, sir.
Okay, sige. Thank you. Thank you, Bern. Thank you.
Sir.
Yeah, ganun guys, ha, para hindi tayo naghihintayan kasi baka tapos na kayong lahat, tapos pala, yung sayang yung minutes eh. Ngayon, I feel that every minute counts. No? So mag-meet tayo sa Thursday, tapos mag-upload pa ako ng isang video on Saturday. And then sa Tuesday, mag-open ako ng session guys. I'll make it 1 to 4 or 1 to 5. And it's, again, since mag-record naman talaga ako ng might as well open it for some who will attend. If you cannot attend, okay lang guys. If you can attend partially, okay lang din. No? Pero siyempre, mahirap mag-attend ng in the middle kasi hindi mo na masusundan yun. So if you're going to attend na lang kayo sa simula. No? Okay, lahat okay na? Bern, meron ka ng SchemR?
Yes sir, meron na sir.
Alright, sige. Tapos, import na ng yung file natin, yung wage interact. Okay, hindi ko pa ano pala to. Right. We did this last time, guys. Okay, and we have 11 variables, di ba? Yung wage natin yung nasa column 11. And then you have this. Meron tayong education, experience. These are quantitative, continuous variables. Then we have female, non-white, non-union, female education. These are your interaction variables, guys. Ito yung ginamit natin nun sa RealStat, if you recall, dun sa Excel. We are redoing it in R. Okay, para alam natin kung Excel man gagamitin nyo or R, you know both. But of course, R is more powerful. Tapos, mas na-improve din sa Excel because of the RealStat na add-in. Okay, so let me go back here. Now let's take a look again at the structure. Okay, these are commands that are used for data analysis, for descriptive statistics. Alam natin si structure. Okay, so I'll do this one at a time kasi minsan pag pinagsasabay-sabay, hindi nakukuha lahat. No? So structure, yan. May mga nakikita tayo dito na hindi dapat. For example, si female, si non-white, si non-union, they are numeric daw, pero hindi naman talaga sila numeric. Itong tatlong to. These are categorical variables. These are factors. The rest are numerical. Okay lang yun. Kasi yung quantitative variable times a interacted with a factor will be a numerical variable. Okay, then describe, guys. You know how this looks like. Ito lang i-highlight ko. Control Enter. Saan siya describe? Yan. Okay, so this is another different way to show the descriptive statistics. Ang gusto ko guys describe kasi binibigay niya yung even the skewness and the kurtosis para makita natin kung ano dun sa mga data natin ang normally distributed. Okay? So I leave that to you guys. Ang suggestion ko, wag niyo kakalimutan yung measure ng skew, ng kurtosis. If you have forgotten that, konting review lang, kaya nyo naman yan kung ano yung ibig sabihin ng mga yan. Kasi gagamitin yan sa research din yan. And then this one, I think this is the first time that you're meeting this. I-run natin si Skim. This is again another good way to present your descriptive statistics. So may data summary tayo, name of the data set. ilan yung observations, ilan yung columns. Okay, tapos kung may group variables daw, wala. Then what's good about this is that meron tayong histogram, parang maliit na mini histogram dun sa dulo. Okay, so makikita natin to. Tapos given din dito yung ano natin, yung minimum, first quartile, second quartile, third quartile, and the maximum. Tapos nakalagay din kung may mga missing data. So walang mga missing data, okay, n missing kung ilan yung number of missing data. Okay, so that's what the scheme function does. No? Okay, so last time we started with forward regression using p-values and forward regression using AIC. So medyo magkaiba yung result nila na napansin natin. Forward na p-values, talagang since nag-set tayo ng p is equal to 0.05, hindi niya isasama yung mga variables na may p-values, probabilities na greater than 0.05. On the other hand, si Akaiki, forward tayo, no? Magdadagdag siya ng magdadagdag as long as bumababa yung AIC. Once na nagdagdag siya, tapos tataas yung AIC, stop na siya doon. Okay, so let's run this. Sabi natin yung model natin. We're going to name our model as model, and then we're going to use this sa lahat ng regressions natin. And the linear model, ito yung base R natin, LM, and then your dependent variable wage regressed on itong mga to, no? Yung liman to. By the way, guys, there's a shortcut for this. Kunyari yung dataset natin, lagay ko dito, insert. If you have, for example, 100 independent variables, of course, excites na yun, ano? Ang tagal isulat niyan. There's an easy way to do that. Control C, Control V, okay, wage, and then tanggalin nyo na lahat ng mga ano yan, okay, and then dot. Okay. So yung dot na yan, ibig sabihin lahat ng mga variables dun sa ano sa data natin. Kaso nga lang wait. May observation tayo, isasama niya to. Dapat hindi natin sinama si observation. Okay? Kuha nyo guys. So siguro I'll leave that to you as an exercise. Tanggalin niyo yung observation doon in whatever way. Pwedeng dun sa CSV, tanggalin niyo na. Okay? And then you can regress guys yung model nyo by not having to write all the predictors. Kung kasama lahat, kung kasama lahat, ito yung shortcut. Lagay natin shortcut. If all IBs, IB guys, independent variables are included. Okay? So I won't do this anymore guys kasi may observation, masasama si observation. Okay, so let's run this. So yung model natin, lahat ng mga regressors natin kasama yung mga interaction, and the complete code is isasama natin yung si data is equal to wage interact. And then we'll call our model forward fit. Okay, so si OLSRR, ang code niya, OLS step forward P. So very intuitive yung code sa OLSRR, no? And then open parenthesis kung anong model na yan, tapos ano yung parameter natin dun sa entering variable na P. Dapat hindi lalampas ng 0.05. Okay? So let's run this. Run. Okay, so nagka-model na tayo na object. Yan, model. At saka yung FW fit P. So we're now ready to ask R to generate that model. Ito na. Kasi hanggang sinulat lang natin yung model eh. No? Ito ngayon, okay, run this, and then it will give us the final result. Okay, so ilang steps daw yung forward integration? Anong nangyari? 6 steps siya. Yung una, ang pinasok niya education, si Akaiki 8688. And then hanggang huling-huli, pinasok si non-union, okay, ang Akai key, it dropped from 8688 to 8484. And then ang sinasabi nito guys, na forward regression na to, pag magdagdag pa siya ng pang-pito, if it adds the 7th independent variable, the p-value of that variable will be greater than 0.05. So hindi pa pwede yun. Okay? You also notice that based on R squared, siyempre tumataas lagi yan. It follows guys, pag nagdadagdag tayo ng independent variables, laging tataas si R squared, but not necessarily adjusted R squared. It's possible that if we add a variable, an independent variable, pwedeng bumaba si adjusted R squared. Right? Lalo na kung may multicollinearity. No? Alright, this is Mallows CP. Parang AIC lang yan. The lower, the better. Ito naman yung root mean square error. Siyempre, pag error ang measure, mas maganda talaga kung lower yung error, yung measure ng error natin. In this case, root mean square error. Okay, then there's another way to do forward regression, this time using AIC. Okay, ito hindi na natin kailangan to, no? Kasi sinulat ko lang dito just to remind you, pero existing pa yung model na yan. Diba guys? Tingnan sa objects natin. Andiyan pa yung model na yan. And we're still going to use that model. This time, ang gagawin natin is, dito na pala tayo, sorry. Dito guys, ang gagawin natin, FW forward fit.aic. This is the name of the object. And then, ang model natin ngayon, OLS, stepwise forward AIC model. Okay? So this time, AIC model yung gagawin. So let me run this. Control Enter. Alright. So nagka-object na tayo na, ayun, FWD fit.aic. Okay? So and then let's ask R to generate this object. Okay. So based on AIC, ilan yung variables natin? 1, 2, 3, 4, 5, 6, 7. Okay, 7 siya. No? Pareho ba yung entry nila? Education, experience, female education, non-white education, female experience. Okay. Parehong-pareho guys yung entering. Hindi sila magkakaiba doon kasi although ang ginagamit ni AIC, ang basis niya, AIC, while yung p-value kanina, yung p-value, of course, yung p-value, pero more or less, pareho yung ipapasok nila na variables. Ang difference lang guys, dito sa AIC, may nadagdag pa na variable. Kasi by introducing female, bumaba pa rin yung AIC niya. 84, 84, 84, 83. Although guys, yung ano nito, yung p-value nito is 0.09, no? So hindi na siya pumasok dun sa ano sa dito sa p-value kanina. But what if we, kunyari guys, ginawa natin itong 0.10. Sige nga, let's experiment 0.10. What if we made this 0.10? Okay, what will happen to our model? Run natin, run. Okay. Tapos run ulit. Oh, ano nangyari guys?
Pasok na si female, sir.
Pumasok na si female. Kasi in-adjust natin yung p-value natin. No? Okay. So is this already the best model guys? Based on p-value? Yung final model na ba to? Answer guys?
Pwede, sir.
As far as model selection pa lang is concerned. Pero yung final na, hindi pa kasi we will have to go through diagnostic test. I-check pa natin to. Remember, itong 7 variables na yan. Ang grabe yung multicollinearity yan. No? If you recall guys, yung nag-excel tayo, nung lineal stat natin, grabe yung VIF nito, 29, may 24 yata, at saka 30. So although sa model selection, ito na, no? Based on p-value. Pero that's not at the final. Parang ano pa lang yan, parang preliminary. We will have to go through the steps of diagnostics to really come up with the model of choice natin. Okay, clear yun guys? Remember, ano pa lang to model selection pala yung process natin. I just illustrated to you na pareho lang yung AIC at saka ano, yung itong p-value kung ginawa nating 10% itong p-enter natin. Any questions, guys? And it turns
None,
out,
sir.
okay, good,
None,
thank you.
sir.
It turns out na yung female natin, guys, lowest siya, no, in terms of Akai key. Pag nagdagdag pa ulit ng isang independent variable dito, tataas na yung Akai key natin. Okay? All right. R squared, 32,995. Tumaas nga yung R squared. Okay, dito, adjusted R squared, tumaas pa rin. No? Okay. But as far as forward regression using Akai key is concerned, ito yung mga predictors natin. So we 1, 2, 3, 4, 5, 6, 7. Ilan yung natanggal? 5. Limang independent variables. Okay. Now let's go, guys, to okay. We can run this code, guys. Itong plot na to papakita kung graphically lang kung paano tinatanggal yung mga ano yung mga pumapasok na na okay, yan. So this is our plot. Kita nyo, no? Since this is forward regression, pag forward regression, ang ipapasok daw niya, una si education, tapos si experience, tapos si FEM education, non-white education, female education to, female experience, non-union, and then lastly, female. Ito yung progression, guys, and the plot as far as AIC is concerned. Okay? So, pang 7 yung variable na female. Pag sinama nyo pa, guys, si number 8, tataas na yung AIC niyan. Okay, clear, guys? Clear?
Clear.
Yes, sir.
Okay, good, good. Salamat, ha? Clear. All right, next. Okay. Ito, guys, it will run the whole step. No? So, very, very detailed to. Forward fit.aic. Pareho din, idadagdag lang natin yung part of the code na details is equal to true. Kasi kanina dun sa taas, dito kanina, ang default kasi false eh. Dito, hindi tayo naglagay ng details is equal to true, di ba? Kaya hindi siya nag-provide ng details. Ito ngayon, maglalagay ng details is equal to true. I-run natin to, run. Okay, then you will see the step by step, no? Forward regression na gagawin. Okay, still running, nakapula pa siya, hintayin natin. Yan, kita nyo sa console, nag-run siya. Alright, okay na, naka-green na to. Okay, forward selection method, sabi. Candidate terms, andyan yung 11 variables natin. Okay, step 0. Eh, ano yung step 0? Walang, ang code niyan, wage, tilde 1. Ang ibig sabihin niyan ng tilde 1, guys, wala tayong independent variable na ipapasok. Okay? So, you can run that, guys, sa R. No? If you do this, wage tilde 1, ibig sabihin nun, yung average lang ng dependent variable ang model natin. Okay, and then this one, the first table gives you options. No? So, ang sabi niyan, remember forward to, so renamp na niya according to the best. How do I know? Kasi pag education daw ang ipasok, ang Akai key natin 8688. Pag ang non-white experience ang ipasok natin, ang AIC natin 8984. Therefore, pinakamagandang ipasok si education kasi it will give us the lowest AIC. Okay? So nakita natin dito, plus education. Alright, next, step 2. So ang AIC na natin ngayon, 8688. Let's see what happens. Pag idagdag sa experience, bababa. From 8688 magiging 8576. Okay? Alright? Pag ang dinagdag natin, guys, si non-white experience, tataas ulit yung AI, tataas pa yung AIC natin. No good, no? So ang idadagdag natin plus experience. Okay, so nakikita nyo, guys, yung narrative ng output, ha? So AIC natin ngayon, kasi sa step 2, pinasok na natin si education and experience, naging 8576 na, as shown here. No? So ang model natin is now wage, education plus experience, then and so on and so forth to, guys, step by step. Papasok naman si FEM education, bababa yung AIC ng 8500, etc. Okay, you get the logic, guys?
Yes, sir.
Okay, so it's just an iteration hanggang, guys, hanggang step number, ano daw? Step number 6 Okay, nag-add. Okay. Step number 6, ito na yung akaikin natin, 8484. Ito na yung model natin. No? 1, 2, 3, 4, 5, 6. 6 regressors tayo. Ito. Ang sabi dyan, pag nagdagdag pa tayo nito ni female, ano mangyayari? From 8484 magiging 8483 yung AIC natin. Diba? So okay pa to. Kaya magpa-plus ng female. Right? Kaya nagka-step 7. So, ito yung model natin, wage regressed on these independent variables. Now, pag pinasok natin si non-white, what will happen?
Tataas na po yung AIC.
Yes, correct. Thank you. Tataas na yung AIC. So, wala na. Rejected na to. Kaya nga dito, no more variables to be added. So, ito na yung sinabi niya. Sinamarize siya. Ito yung mga variables na pinasok. So, ang final model output natin is, okay, ito na yung summary statistics, R squared, adjusted R squared. Okay, you know this, root mean square error, mean square error, mean absolute error. Pakiano lang guys, these are just measures of error. Madali naman ano yun eh, kasi ito, yung errors is square lang, kukunin yung average niya, tapos kukunin yung square root. Ganun lang yung RMSE. Ito naman, square ng errors, tapos kukunin yung average. Ano yan? Kunin yung average. Okay? Tapos ito naman, absolute error, kukunin yung absolute ng error terms, tapos kukunin yung average niya. Yan o. Root mean square error, mean square error. Of course, the lower these error terms are, measurement of error terms, the better. And then you have the, alam na natin to, si ANOVA. Okay? Ito si significant, value not, significance. P-value is less than 0.05. Therefore, we reject the null hypothesis that, ano yung null hypothesis natin dito? B null is equal to B1 is equal to B2, that is equal to B7. Bakit hanggang B7?
7 regressors.
7 regressors tayo. Plus B null because of the intercept. Okay? Kaya andito siya sa baba guys. Andito siya. Yan. 1, 2, 3, 4, 5, 6, 7. Okay? Plus the intercept. Okay? And all of them are significant at the 10% level. Okay? Clear to guys? Clear? So for example, based on model selection, pwede natin isulat tong model natin. Wage is equal to negative 9.143 plus 1.537 times education plus 0.212 times experience, etc. No? Guys, alam niyo na kung paano mag-ano ng model, guys, Hello?
Yes po.
Okay, so that's
Yes,
forward. Okay, thank you. Forward regression yon. Pupunta naman tayo ngayon sa backward regression. Yung backward regression, guys, ang nangyari naman dito, the-dump mo na lahat ng independent variables isasama, tapos one by one, tatanggalin hanggang wala na matanggal. Yun ang backward regression natin. So again, si OLSRR, dalawang klase, no? Yan, backward regression using p-values muna, and then backward regression using AIC. Sige, run natin. Okay, let me close this muna para we have more space. All right, backward regression. Again, we're going to use the same model, guys. So actually, hindi na natin kailangan i-run to kasi ano pa naman yan, buhay pa yung object na yan, no? Ang kailangan lang natin i-run itong backward. Okay? And then we ask R to generate this, no? Sabay na natin to. Control Enter. All right, ito na yung backward ngayon, guys. Okay. Paano naman to? Paano tong ano nangyari dito? Elimination to, no? So, ano nangyari dito? Out of the 11, ang unang munang tinanggal si non-white. Okay? Tapos, ang susunod, tinanggal si non-union. Non-white, etc., etc., hanggang 84, no? Okay? So, 5 yung tinanggal niya. Tama ba?
Yes po.
Okay. Backward, tapos... Lima. Bakit 5? 0.05. Wait na. Tama ba itong ginawa ko? Tama ito. Yeah, backward fit. Based on p-value. So, tama, no? Tama. I was thinking 12 yung regressors natin. So, 11 minus 5, 11 variables minus 5, 6 na lang. Tama. Pag P6 lang yung significant na predictors natin. Only that, in this case, naka-reverse siya. Ang pinapakita sa atin yung one at a time, tinatanggal siya. Okay, guys, clear? Hello, clear?
Yes, sir.
Alright. Ang question, pareho ba ito dun sa forward na P? Pareho ba siya sa forward na tinanggal ko na, no?
No, sir. Kasi 0.1 po ata yung forward.
Hindi, binalik ko. Binalik ko sa 0.05. Parang experiment lang natin kanina yon. Okay.
Same ata, sir. Kasi tinanggal din yung female eh. Yung ginawa mo 0.05.
Oo. In this case, nagpareho siya, no? 6 din yung 6 sa forward na p-value, 6 yung regressors, hindi kasama si female. Sa backward naman na p ang basis, ganun din, tinanggal yung mga to, kasama si female. So in this case, pareho si forward at saka si backward based on p-value. Usually guys, kapag p-value, nagkakapareho sila. Pero minsan kay Akaiki, hindi. No? So, hindi naman lagi guys na I've seen several models na magkaiba yung nila, magkaiba yung output nila. But oftentimes din pareho. No? Alright, so about this guys, backward using Akaiki, ganun din guys, ang papalitan na natin si P dito, OLS step backward AIC. Sa taas, OLS step backward P. Sa taas naman, OLS step forward P, OLS step forward AIC. So madaling tandaan guys yung code. Pareho lang sa kanya yung OLS stepwise, OLS step. Okay, let's do this. Okay. Pa-generate na rin natin si backward fit natin. Okay, i-generate na yung results niyan. Okay. Nagawa natin ito kanina, di ba? Oh, sorry. Okay, nagawa na natin ito kanina, na-generate natin. So yung plot na lang, guys. Yung plot kung what will the plot give us? Kung ano yung tatanggalin. Kasi backward to eh. No? Backward siya. So unang tinanggal si si non-white, 2, 3, 4. Bakit 4? Ibig sabihin may... Bakit isa lang? 1, 2, 3, 4. Parang kulang. Wait, ha? Diba dapat ang tatanggal niyan 5? Oops. Rinan ko kayo sa console yung command na to. Oops, bakit? No applicable method for depth applied to the object. Why? What's my... Ayun. Ay, tama na ba? 1, 2, 3. Ba't 4 lang? Ay, sorry. Tama. Tama pala to. Sorry, I was thinking of P. Okay, AIC tayo guys. Kaya sa AIC, di ba, ang tinanggalan niya 4? Di ba? How many regressors yung nag-result pag AIC? 5, no? Pinasok niya si female kahit na hindi siya significant at 5%. Kasi pag tinanggal niya, mas mataas yung yung AIC, no? Mas mataas yung AIC kung hindi kasama si female. Okay? So, sorry, I got confused. I was thinking of andito ang laka-laka na stepwise AIC pala to. Okay, guys, questions?
None, sir.
Okay, sige,
None,
good.
sir.
Thank you ah. Okay, so let me, all right. Again, guys, dito, si backwardfit.aic natin, let's have the intermediate steps generated. Okay, this will take some time. Ayan, okay? So, same thing as above, only sa taas, guys, forward yon, ito backward na. Okay, so ganun din, magsisimula muna sa, ito yung initial model natin, lahat. Di ba? Notice the difference between backward regression kaysa forward regression. Okay, forward regression, magsisimula muna sa wala. Ito naman, magsisimula sa lahat ng regressors. Tapos titingnan, kung tinanggal natin si non-white, okay, ang magiging AKI niya, 8486. Pag ang tinanggal natin si education, ang magiging AIC 8536. So, syempre, ang tatanggalin dyan si non-white. Okay? So, parang yung kanina din, X to, hindi plus, di ba? Kita nyo guys yung distinction? X, ibig sabihin remove. Tapos, step 1, step 2, magtatanggal siya na magtatanggal na naman, magtatanggal hanggang pagdating dito. Okay, pagdating dito, ito na yung model natin. AIC is 8483, ang regressors natin. 1, 2, 3, 4, 5, 6, 7. 7 regressors. Okay. Pag tinanggal pa si female, ang sabi dito, magiging 8484 yung AIC. Mas tataas pa sa Karen. Kaya no more variables to be removed. Tapos ito yung summary ng mga tinanggal na variables. Okay? So nakita nyo guys how powerful, how convenient to use yung mga functions na to sa OLSRR. Unlike yung nag-ano tayo kanina, dati, yung nag-Excel tayo, iisa-isahin natin yun. And by the way guys, sa Excel nga pala, sa Excel, yung take-home quiz nga pala guys, naka-ano na sa Google Sheet, ibibigay ko yung link mamaya, and it will be about stepwise regression. Okay, i-compare niyo yung sa i-compare niyo yung sa real stat at saka itong sa R, okay? Parang ano lang, parang binigyan lang kayo ng ibang data and then iraran nyo. Due guys on Thursday. Due on Thursday kasi isa pala yung quiz natin, kailangan baka hindi na ako makapagbigay ng quiz next week. So lulubusin ko na yung quiz ngayong week guys ha. I'm thinking of may quiz pa. Tapos the rest will be project na lang, no? Project. Okay. And then yung finals natin will be I think October something. I-announce pa naman yung schedule. Okay, so again, andito din guys, andito yung ANOVA natin, andito yung individual test natin ng mga parameters. Okay, so this is our model based on backward AIC. Lahat significant and female is significant at the 9.8 at 10% level of significance. Okay? Kung titingnan nyo guys, strictly speaking, tatamaan yung 0 dito eh. Diba? Kasi, however guys, kasi itong lower at saka upper na to, this is at 5%. Kinumpute yan at 5%. Eh, significant siya at 10%, kaya nga tatamaan talaga yung 0. Alright, next is stepwise. Ito yung sinasabi kong stepwise guys, ito yung combination ng forward at saka backward. So pwedeng may matanggal at saka nadagdag na, pwedeng matanggal ulit, o binawas na, pwedeng ipasok ulit. Yun ang stepwise, no? Okay, so
Bye.
yes, questions? May question? All right. Sa pa hindi naran natin dito. Okay, naran na natin. Stepwise na tayo ngayon, guys, no? OLS step both P. So yung kaiba nito sa taas, forward, backward, both. Tapos P din tayo, run natin to, guys. Okay. So ito yung ito yung result. Now it turns out guys na using stepwise, panay addition lang. Pero tingnan nyo yung dito yung label added/removed. So ibig sabihin nun, pwede siyang nagtatanggal at saka nagbabawas. Pwedeng ipasok yung, pwedeng tanggalin yung napasok na yes. Unlike yung forward guys, pag pinasok mo yan, forever na andyan yan. Pag backward, pag tinanggal mo yan, forever nang bawas yan. Si stepwise, pag pinasok, pwede pang matanggal yon. Pag linabas, pwede pang magawa. No? Okay. Alright, so, san pareho si guys? San pareho si stepwise yung result? Pareho siya kay
Sir, yung forward po.
kay forward. Kay backward. Pareho din siya, no? Pareho din kay backward na P, no? So yung mga P, pareho sila whether forward, whether backward, or stepwise. In this case, nagkapareho sila, no? Okay, so let's go now to any questions here, guys, sa stepwise. Ang importante lang dito, guys, the model will look for possible na maidadagdag based on p-value. Later on, pag nagdagdag, tapos hindi siya naging significant, tatanggalin niya yun. So yun na, as I said, guys, yun napasok na sa model, pwedeng tanggalin. Okay. Yung hindi pa napasok, pwedeng ipasok, pero pwede pang tanggalin yun. Okay. Yung natanggal na, pwede pa ulit ipasok. Okay, so para mas flexible yung stepwise. Pero pag ima-manual yan, guys, mas mahirap. Alright, so let's na-generate na natin, ano? Na-generate na natin. Ay, naulit to. Akai key naman pala to. Based on Akai key, guys, what do you have? Okay, ganun din si Akai key, no? Stepwise. Pero kay Akai key, 1, 2, 3, 4, 5, 6, 7. Okay, 7 yung regression siya. Parang pareho ng ng forward na Akai key at saka backward na Akai key. And lahat anong nangyari, para exactly the same siya as forward na Akai key kasi lahat addition. Remember guys, stepwise nagsisimula yan sa forward, no? Ibig sabihin, wala mo ng regressors. Okay, and here it so happened that pareho siya ng forward lang. Wala nang tinanggal ulit na pinasok na independent variable. This code will again generate yung plot. Yan. Okay. So, sabi nga natin, lahat pinasok. Walang linabas. No? Okay, and then, kung gusto natin guys makita yung intermediate steps, alam niyo na to. I-run ulit natin to. We just added details is equal to true. Yan. Tingnan nyo guys, oh. Si stepwise nagsisimula talaga siya sa water lang. Si stepwise nagsisimula siya sa walang regressor. Okay? Then magdadagdag siya. Magdadagdag. Then, sabi ko nga guys, pwede siyang magbawas. Pero dito lahat dinagdag niya. Wala siyang binawas ulit. Wala siyang binawas na dinagdag na niya. Okay, so straightforward yung model na to. Okay, then we have the same. Clear so far guys? Clear?
Sir?
Yes?
So, bale, same lang yung backward, forward, tsaka yung both. Magkakatalo na lang lahat yun sa diagnostic.
Dito nagkataon lang. Wait, hindi pareho yung kasi may forward tayo na P at saka forward na AIC, di ba?
I mean, sir, if kunyari forward AIC tapos backward AIC,
step,
yes, lahat.
Nagkataon lang.
Okay, sir.
May mga times na hindi sila pare-pareho.
Okay, sir.
Sabi ko nga, in general, kunyari parehong AIC, in general, pareho yung maging output. But there are certain circumstances, there are certain instances na hindi pareho. Okay, Bert? Clear?
Thank you, sir.
Okay, sige. Alright, now, ilan yung regressors natin, guys? Di ba meron tayong education hanggang kay non-union experience? 11 yan, guys. 11. Now, do you know how many possible regression models we have? Oh, pwede. Una, let me just enumerate. Una, si education lang. Pangalawa, si experience lang. Pangatlo, si female lang. In other words, lahat ng mga independent variables ito, pwedeng sila lang yung regressor. Right, guys? So that's already 11. You follow, guys?
Yes,
Yes
sir.
po.
And then, pwede i-prepare natin. Education and experience. That's another model. Education and female. That's another model. Education and non-white, etc., etc., etc. So all in all, guys, ang ano niyan, 2 to the number of regressors, and I think may -1. So 2,047 models ang pwede, guys. So combinations nito. Gets you, guys?
Yes, sir.
Pwedeng isang variable muna. Tapos pwedeng tagalawang variables. So marami yan, yung combination ng tagalawa. Nagtatatlo naman, ang daming combination ng 3. Ang daming combination ng 4, 5, 6, 7, 8, 9, 10. Yung 11, iisa lang yun, di ba? Kasi kasama na lahat. All in all, guys, there are 2,047 models that can be regressed, no? Tapos kaya ba ni Aryan? Yes, kaya i-generate ni Aryan. Okay? Eh, kaso, hindi naman kailangan lahat i-generate kasi ang dami nun, 2,000 models yun. Okay, so pero gawin natin, no? Ito. Saan na tayo? Here, I'm in line. Yan, line 151, guys. All possible subsets regression. So ang code niyan, guys, OLS step all possible. Okay, guys? All possible. So let's give it a name, model compare. Okay? Mod compare, and then let's run this. I-generate ni R lahat ng mga possible na models. Run. Okay, hintay-hintay lang tayo, guys, kasi it will take some time. No? Maybe a minute.
Sir,
Yes.
for yung take-home exam po, kaya po bang Friday na lang po ba yung submission if it's okay with you?
Tanungin natin class. Anong gusto niyo, class? Mamaya yung submission o Friday?
Ha? Mamaya po, sir?
Obvious, di ba? Gusto nila Friday, syempre. Sige, sige. No problem.
Thank you, sir.
Thank you,
sige.
sir.
Thank you,
Pasensya
sir.
na, hindi ako nagbigay ng mga dati kasi actually talagang medyo, ewan ko ba, hesitant ako mag-ano eh. Parang I was trying to understand yung situation na ang hirap ngayon na ano. Ayun, parang kaya na-postpone hanggang matatapos yung term. Sabi ko, hala, iisa pala yung quiz namin. So kailangan magbigay ako ng 1 or 2 this week. No?
Sir, ilan po ba dapat yung quiz natin for this term?
4 sana eh. Para at least tingnan natin kung ano. Pwede naman ako magbigay ng activity at tapos tatawagin ko na question. But I'll be very nating flexible na lang. Alright, guys, tingnan nyo to. Tingnan yung result, no? Ano yung result na to? So you have index 1, n, predictors, r squared, adjusted r squared, mallows CP. Dito ang dinalagay mallows CP. Meron pa bang iba? Mallows CP, no? Okay, tingnan natin ha. Let's just briefly look at this. So, yung n is equal to 1, ito lahat ng mga single predictors, no? Yung mag-isa lang siya. Kaya 1 lahat yan, no? Kuha, guys. Hello?
Yes, sir.
Diba?
Yes
Ito.
po.
Yan. Yan. Tapos, ang susunod nito, lahat ng 2, ibig sabihin, lahat ng combination ng dalawang variables na regressors. Yan, lahat yan. Lahat ng 2. So, tapos lahat ng 3, lahat ng 4, lahat ng 5, lahat ng 6. Okay? So, bumigay na nga dito yung ano eh. Nag-omit na ng 1881, no? 1881. Paki-add nga, wait ha. 1881 plus 1881 plus 166 kasi 166 na to eh. Ilan yung guys? Ito 166 rows na to ng regressors plus 1881. Kuha? Hello class? Kuha?
Yes, sir.
Ilan lahat yun? 2047. Di ba yung kanina ginawa natin yung 2 to the 11 minus 1. Okay, di ba?
Yes,
Yun yung
sir.
formula guys, 2 to the k minus 1. Yung k natin yung number of regressors. Pareho, 2047. Okay? So, I think naka-table to, no? Let's see. Okay, hindi ko kinuha yung structure. Okay. Naka-table yan, guys. Check lang natin. Dito na lang. Class mod compare. Data frame siya. Ha? Data frame na pala siya? Kala ko naka-table siya. Okay. Anyway here guys, I was thinking na naka-data frame na naman siya eh. Sige, anyway, let's just run this. Okay, yun na nga yun. No? Tapos dito, iba na na-generate niya. No? As data frame, tama. Hindi pa nga siya data frame. Anyway, nung kinonvert natin class into a data frame, itong as.data.frame, si mod compare, kaya tingnan mo, iba na yung iba yung output. Yung predictors R squared, better than the output kanina. Okay? So anyway, guys, tapos ang gagawin nyo, titingnan nyo yung pinakamaliit na AIC o mallows dun sa 2047. Bernd, gusto mong ikaw gumawa nun?
Sir, iba yung iba yung nakaiba sa akin, sir. Hindi siya nakalabas lahat. So, bale parang by page siya.
By
Ganun.
page. Okay lang yun.
So, kailangan kunyari page 1, tapos page 2, page 3 hanggang 100.
Kanina may paging yata ako dito kanina eh. Dito Hindi ko na nakita. No? Pero okay lang yun. Pero kasi guys, do we really need the 2047? Gusto mo mag-volunteer, Bernd, na ikaw maghahanap ng doon, ng lowest na AIC?
Okay lang, sir.
Joke lang. Grabe, ang tagal nun.
Iisa-isahin ko, sir.
Oo, iisa-isahin mo. Hindi. I-plot muna natin, guys. Pakita ko lang tong code na to. Yung plot, ipa-plot natin si mod compare. Okay, then let's see what happens here. Okay, ipa-plot dito yung based on yan. Ilang diagrams to? 6 na diagrams. Okay, let me just explain this. Visual lang to. Kung gusto nyo guys sa mas malaki, pwedeng dito, Control C. Pwedeng dito yung sa console i-run. Kasi pag sa console yung i-run, magge-generate siya ng na pwede natin i-zoom. Okay? So ito yung page 1. So what do you have here? So you have here, guys, based on certain parameters, R squared, mallows, CP, adjusted R squared, AIC, etc. Ito yung SAWA, Bayesian information criterion, Schwartz Bayesian criterion. Okay. Ang sinasabi sa atin dito, let's see. I'm trying to expand hirap mag-expand. Anyway, ayan. Okay, what is this? Ano itong mga triangle na to, guys? Okay, this means that kung iisa lang yung regressor, Itong triangle na to, siya yung best. Okay, in terms of R squared. Sino to? Si Model 1. Sino ba yung Model 1? Yung sa output kanina, yun yung education lang. No? So dito guys, itong mga to, this tells us, kunyari kung 9 variables in terms of MALO CP, ang best is, what's this? Model 1982 yata, 1982. So hahanapin mo kung ano yung model 1982 in terms of 9 independent variables, etc. Gets guys? Gets? Gets? Yung x-axis, yan yung number of regressors. Okay, yung y-axis, that's the measure, depende dun sa factor, yung R squared, CP, AIC, etc. And yung mga naka-triangle, as far as, for example, ito, tingnan natin to guys, ito. Ano ibig sabihin nito? Kung 3 regressors ang gagamitin, based on AIC, model 67 is the best. Okay, so, kung bumalik tayo dito, asan na si model 67? Yan, yung index na yan guys. Oh. Model 67, yan. 3 regressors. Okay. Yan. Among the 3 regressors, guys, among the combinations of 3 regressors, ito yung pinakamaganda. Education, experience, female times education. Dito sa list ng 3 regressors, what do you notice, guys? It's arranged according to, yan, naka-arrange siya by the lowest, dito, lowest, MALO CP nakalagay dito, Kuha, guys?
Yes, sir.
Okay,
Yes
so
po.
yung plot na yan, may ibig sabihin yan. No? However, yung all possible na yan, medyo parang, ba't natin pakailangan ng, ng 2047, na options. Pwede na lang natin guys, to. Okay, ito na lang, guys. The all possible model gives us all possible regression models. Sabi mo nga kanina, kulang to 2 to the n, gawin natin 2 to the k, where k is the number of regressors. K, number of regressors. Okay, number of regressors. And however, we can use the best subset regression as an option. So ito yon. Again, let's call it mod compare ulit, no? OLS step best subset model. Okay, so ang difference nito, ito all possible, ito naman best subset. Okay, let's run this. Tapos anong binibigay nito, no? Yung best subset, yung based sa number of regressors. Kung isang regressor lang, sino yung pinakamaganda? Kung dalawa, sino yung pinakamaganda? 3, 4, 5, etc. Let's wait for the output. Daran pa siya. While we're waiting, guys, pakibukas yung dun sa module 6, I sent an R markdown file there. Structural form, mali nga yung date ko, dapat September 2020. Okay, while we're waiting for this to run. Okay. Kaya siya nagtatagal, guys, kasi tinitingnan niyo lahat ng out of the 2047 models, no? Ayan. Okay. So, anong ibig sabihin nito, guys? Yung best subsets regression, titingnan niya, kung isa lang, guys, daw yung predictor, education lang yun. Kung dalawa yung predictors, education times experience. Kung 6, yan. Education experience na yun. Looks familiar, guys? Ito yung na-generate natin kanina based on p-value, yung 6 na to. Okay? So ito yung sinasabi niya na kung lahat ipapasok mo, well, iisa lang naman yan, no? Kung 10, sino yung tatanggalin? Kung 9, etc. Okay, and then you have this one. Okay. All right. Model. So out of those 11, ano yung pinakamaganda dyan? Okay, syempre, ang mga tinitingnan natin, for example, based on adjusted R-squared, sinong pinakamaganda? Guys, based on adjusted R-squared, sino pinakamaganda? Before that, based on R-squared, definitely yung model 11, di ba? 3328. Di ba sabi natin, kapag ang R-squared, tataas lagi ng tataas yan pag nagdadagdag ka ng independent variable. But not adjusted. Si adjusted, in fact, pinakamaganda niya yung 8 regressors. Pero sabi natin, we don't stop there kasi there are other factors that we may consider. Kay Mallows, guys, sino yung pinakamaganda? Kay Mallows CP, sino?
Sir, Model 7.
Model 7, no? Model 7 si Mallows CP. Okay? Pareho siya kay AIC. No? Si AIC Model 7 din. Si SBIC, ganun din. Si SAWA, si SAWA's Bayesian Information Criterion. Si SBC naman, si Bayesian or Schwartz. Bayesian Information Criterion or Schwartz Bayesian Criterion. Sinong pinakamaganda sa kanya? Sa kanya si 6, di ba? Ay, hindi. Sa kanya si ano pa nga eh. Si
4th ata, sir.
Si 5.
Ay, 5.
No? 5, ano? So nakita natin medyo may konting difference, ano? Et cetera, et cetera, et cetera. No, hindi natin tinitingnan dito yung meron pang Amemiya prediction criterion, Hawking's SP, okay? Suffice it for us, guys, sa mga advanced na kahit sa mga advanced, hindi naman masyadong pinapansin to eh. Okay, so si Akaiki, si SBIC pareho, si SBC medyo iba, no? Okay, si Mallows pareho kay AIC. All right. But again, guys, model selection pa lang yan. Remember, okay? Remember, mag-ano pa tayo niyan, the diagnostics. Okay, and lastly, i-plot natin yung yung mod compare based on best subset. Okay. Halos pareho lang din to ng ano. Okay, based on R-squared, guys, understandable ang pinakamaganda yung 11 variables. Okay. Based on adjusted R-squared, yung pinakamataas dyan, somewhere here, parang ito yata. No? Although mahirap tingnan visually, si CP, Mallows CP, medyo dito din. No? Okay, ganun din si AIC. Meron pang SBIC at saka SBC. Okay, guys. Any questions? Any questions?
Sir.
All right, good. So that ends our discussion on stepwise regression. So every time, guys, kunyari sa assignment nyo, stepwise yun sa take-home quiz nyo. Kasi bibigyan kayo ng 16 o 18 yata na variables. Tapos, kung ano mo yun, isa-isa mo sa Excel yun, matagal yun. At saka by the way, sa Excel, may limit na 16 lang na independent variables. So paano kung nag-20 na kayo, 20 na independent variables? Hindi na pwede sa ano. Pero pwede kay real stat, no? Yun ang kagandahan naman kay real stat, yung add-in natin, kahit na mas maraming independent variables, kaya pa rin niya. Pero kung kay Excel lang, hanggang 16 lang siya. Okay, so what now, guys? Open the other file that I gave you. The next topic we're going to discuss is itong structural form. Kasi so far, ang pinag-uusapan natin, guys, paano yung ang variable natin, let's say wage. We haven't discussed, guys, paano kung linog natin yan, log wage. Okay, that's where structural form comes into play. And how do you interpret that? Okay. By the way, guys, aralin yung interpretation ng final model dun. Actually, yung next step dapat dun, yun ang ibibigay ko rin sa inyo as an added assignment. I-diagnose nyo, guys. Kasi meron na kayong model 1, yung 6 na variables, yung model 2, yung 7 variables, yung kasama si female. Ngayon, titingnan nyo kung sino ba talaga mas maganda doon. Based on multicollinearity, based on yung ANOVA, di ba? So you have to look and see. Then it tests for heteroscedasticity, it tests for, I said, multicollinearity, heteroscedasticity, and yung residuals natin, yun yung heteroscedasticity. At saka yung autocorrelation, hindi siya tinetest kasi cross-sectional naman yan. Yung autocorrelation, tinetest lang yan kapag time series. Okay? All right. We have a few more minutes, guys. Sige. Let's see what we can do with this. Now, dito marami tayong guys, sa diagnostics, marami tayong pwedeng magamit diyan, no? Have we installed Broom before? Naalala niyo ba?
Sir,
Parang meron na po.
Si Car, na?
No pa po. Core plot, car, forecast, Gigali. Pababa po, wala pa po. Except for Stargazer and OLSRR.
Meron pa. Mas wala pa?
And Gplot. Mas,
Gplot meron na rin.
parang, not sure po sir, pero parang meron na rin po. Pero I'll try downloading it po.
Sige, i-ano nyo lang guys, i-download nyo. Tapos i-import natin si OLK data. OLK binigay, I posted it guys sa Sige, let's do that. Tingnan natin kung saan tayo aabot ngayon. Okay, this will take some time. Dapat pala sinulat ko yung install.packages, I forgot. Para mabilis na yung nyo. I'll give you a few minutes, guys, to... Ano nangyari sa GG45 ko? Hindi ko pa na-install. Hindi ko pa rin pala na-install si GG45. Then, hindi ko pa pala na-import. Import dataset from base.
Sir,
Yes.
Okay po. So OLK po yung ita-download po, no?
Which one? Yeah, si OLK.
Thank you, sir.
Okay. How are you guys? Sino hindi pa tapos mag-download?
Sir, installing pa po.
Sige, okay. Take your time, sige. Okay na, guys? How are you?
Okay na po for me, sir. Pero,
Okay, the
Ako rin
rest?
po.
Okay, meron pa bang Okay, sige. Looks like okay na tayo, ano? Alright, na-download nyo na rin si OLK. OLK is, let me show that. Output, labor, capital. So in economics, established theory niya na yung output is a function of labor and capital. So we're going to derive a model, a regression model, where we're going to regress output on labor and capital. Pero ang uunahin natin, maglo-log tayo. Ano ba yung gamit ng log, guys? I think I showed this to you before that yung log, nasa scale niya yung data. Lalo na pag mga econometrics data, kunyari GNP, GDP, katulad nito, output, they run into billions. Tapos if you work on that data, mas matagal yung pag-run o mas mahirap kasi it's usually very big. So, kung in-scale natin kung log, nare-reduce yan into less than 10, no? And it makes the manipulation of the data a lot easier. Okay, so let's go here. Okay, now, na-view na natin. Ano ba yung structure? Tingnan muna natin. Structure. Structure ng data natin, it's a data frame with 51 observations and 3 variables. You have integers sila, no? Output, labor and capital, lahat mga integers. Okay. And then here we're going to, you see, sa OLK data natin, we'll call it log output. And we will get the log. Remember sa R, guys, ang log, it's base E, no? Hindi siya base 10. OLK, and then output. So we're going to convert our data, into, instead of just output, ilolog natin sila. So i-run natin to, yung tatlong to, run. Okay. So ano natin, guys, so we created an object, no? Doon sa OLK natin, we created 3 objects. Nag-create tayo ng log output, log labor, log cap. So yung OLK natin, ando doon pa rin sa output, labor, capital, pero meron ng log output, log labor, log cap. Let's look at that. Okay, tingnan nyo, guys, so na-scale na siya, no? Yung output na, this is 38 million ba to? 38 million, 17 point something na lang. Okay, so that's the advantage of scaling your data. And usually, pati sa finance guys, sa mga returns, linolog din usually yan for scaling purposes. Okay, so let's go back here. Okay, so nalog na natin sila guys. Okay, mag-correlation matrix tayo. Remember guys, sabi natin, gusto natin si independent variable, si log output, highly correlated with log labor and log capital. But we don't want log labor and log capital to be highly correlated. Sige, kunin muna natin itong pairs. Okay, so we have here the pairs function. Ano? Dito si log, yung command na to guys, so pairs, sino ipipair natin? Si log output, log labor, log capital, dun sa data ng OLK. And you find here, si log output, highly correlated with log labor. And highly correlated with log labor and highly correlated with log capital. Ang problema lang guys, si log labor at saka si log capital highly correlated din, no? So we might have problems with multicollinearity on that regard. Okay, and then you can use this GG pairs. Okay, this is also yan. Oops. Oo, nag-error ako. Bakit ako nag-error? Ito, okay. Yan, okay. I like GG pairs, guys. This is from, saan ba galing to si GG pairs? GG Ali yata, or if I'm not mistaken, either GG Ali, GG Ally, or GG 45. Okay, tingnan nyo guys yung GG pairs, ano? Kaya dito natin para mas malaki. I'm going to run it here. GG pairs. OLK. Advantage kasi dito guys na zoom natin, no? Yan, okay? I prefer sometimes yung mga plots dito sa console i-run. Yan. Kasi mas maaan natin, and you can copy this. You can copy this kunyari sa ano nyo guys, sa homework, sa toy quiz nyo, you can make use of this and then discuss, no? Tingnan nyo guys, no? So andito yung ano nila, yung scatter plots nila. Okay? Kasama lahat, no? Si log labor, output, labor, capital, and log output, log labor, and log capital. We're interested in log output. Okay? Log output with log labor. So si log output, nasa na yung correlation niya? Log output with log, this is log output with log labor, ito. Ito yung plot niya. Okay, what's the correlation? What's the correlation, guys? With log output and log labor.
Positive, sir.
Saan? Ilan? Log output and log labor, guys. What's the correlation? Ano? Ito. Log labor, log output, no? Ito. 0.971. Okay, that's good, no? Kasi log labor, log output is our dependent variable. Si log capital naman at saka si log output, okay din, mataas, 973. Ang problema natin guys, sino? Si log labor at saka si log capital, ano yung ano nila? Ano yung correlation nila?
0.75.
Saan? Where is that?
Log labor tsaka log capital.
Oh, ito, log capital, log labor, yun, no? Diba? Tama, guys? 0.96, that's very high, no? O, ako, nahuhulaan ko na magkakaproblema tayo nito sa multicollinearity. Okay? So anyway, sige, i-ano muna natin, tuloy natin. Clear so far, guys, yung ano, yung yung paggamit natin ng mga packages ni R, especially si GG, Ally, at saka si GG45. Alright? About this. Ito, let me see kung tama yung syntax ko nito. Mukhang I limited it to, nag-error ako. Let me check this guys. Kanina, when I was doing this, talaga nag-error ako eh. Kasi ang gusto ko lang yung tatlong to lang guys. GG pairs lang, not the whole OLK, but only, kailan ba yung, wait, let me check. Hindi yan. Okay, check ko yung ano guys ha. Hindi ko maano kung ano yung mali ng syntax ko nito eh. But anyway, ang gusto ko lang naman gawin dito, gumawa ulit ng to make another GG time na pala. GG pairs guys na ang laman lang hindi lahat ng 6 but just the log labor. All right, it's already almost time guys. Let me just run this, no? So nagmo-model tayo, model 1, i-linear model natin si log output with log labor and log capital. All right. So sige, hanggang dito, hanggang summary 1. Let's run this, control enter. Okay. So, what do you have here? Okay, ito kino-call out yung formula natin. Residuals. Okay, kita natin na medyo median 0.05. Tapos significant lahat, no? Significant lahat. Right, guys? Hello, guys? Significant
Yes,
lahat?
sir.
Okay. So, anong interpretation nito? Pag pareho naka-log, guys, this is by the way what you call a log-log model, no? Sulit ko siya dito. Yung ginawa natin sa taas, it's called a log-log model. Double log kasi parehong yung dependent variable mo at saka independent variable mo pareho naka-log. And we'll continue with this next meeting. Ang interpretation nito guys, for every 1% change in your log labor, there's a corresponding 0.46% change in your log output, ceteris paribus. Okay? Take note of that guys ha. Pag parehong log, ang interpretation hindi unit. Mawawala yung unit, magiging percent lang. Okay? Magiging percent lang. For every 1% change in your log labor, there's a corresponding 0.4683% change in your log capital. For every 1% change in your log capital, there's a corresponding 0.52% change in your log output, sorry. All right? So we'll continue with this next meeting. Guys, kung pwede sana, tingnan nyo ha, kasi ito, magko-compare na ng mga models dito, no? Diagnostic na to, no? Pupunta na tayo sa diagnostics, guys. And then tuloy-tuloy lang hanggang yung susunod na model dito is saan na siya? Is ito, log-lin. So tinitingnan natin sa taas, log model or double log. Ito na yung structural forms, guys. So may log-log, may log-lin, may lin-log, etc., etc. Okay? So, sige guys, thank you so much for your time. And sorry, nag-extend na ako. I'll see you on Thursday.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
All right. Sige.
Thank you, sir.
Okay.
Sir,
Yes?
sir, I was late kanina.
Sir, yung mga late, hintay ha. Anong name?
Sir, ipopost pa lang po yung assignment, right?
Papost ko pa lang. Mamaya, ha?
Okay, sir. Thank you.
Thank you, Bern. Name, please.
Alisa Yao po.
Okay, dali lang ha. Can you see the screen?
No, sir.
Hindi ba? Hindi ba naka-share? Hindi lang, nag-load pa.